If you've ever buckled into an airline seat, looked out the window, and just wondered, how does all of this actually work? Well, you've come to the right place. Consider me your captain for this explainer. We're going to navigate through the science and some of the incredible stories that really shape your experience in the air, and hopefully turn a little bit of that mystery into understanding. So let's start with a big one. It's probably the most common question I get, and it's one that can create a little bit of anxiety before we even push back from the gate. Yeah, I'm talking about that emergency exit door. We've all had that fleeting thought, right? What if someone tried to open the door? And when you see some of the headlines out there, you might even start to wonder if it's possible. The thought of it is frankly terrifying, but the reality is all about some surprisingly simple physics. Okay, so this did happen back in May of 2023. But here's the key detail you have to know: when it happened. This was not at 35,000 feet. The plane was on final approach, really close to the ground. That means the pressure difference between the inside and the outside of the plane was tiny, almost nothing. So what keeps us safe the rest of the time? Well, this is where the design is just brilliant. Most aircraft doors are plug doors. Just think about it like a cork in a bottle. The door is physically larger than the hole it's sitting in. That means the pressure inside the cabin, all that air pushing outwards, is actually what's holding the door shut, sealing it into the frame. The plane's own atmosphere becomes the lock. And to put that into perspective, when we're up at cruising altitude, the amount of force pushing on that door is equivalent to about 9,000 kilograms. So could you open it? Not unless you can lift a school bus. It is physically impossible for any human to overcome that much pressure. The plane literally locks itself. All right, so that cabin pressure is obviously super important. But that brings up another question. Why do we bother climbing all the way up to 35,000 feet, 10 kilometers up into the sky? It's not just for the view. Now, sure, getting above all the clouds and weather makes for a much smoother ride, and that's a nice bonus. But the real reasons we fly so high are all about efficiency. The air up there is incredibly thin, which means way less drag, so we can go faster. On top of that, jet engines just love cold, thin air. They run way more efficiently, and all of that adds up to massive fuel savings. And the numbers really tell the story here. Look at this. During the climb, we're burning about 80 kilograms of fuel a minute. But once we get to our cruising altitude, that gets cut in half, down to 40. And on the way down, it's next to nothing. So that big, fuel-guzzling climb is really an investment that pays off big time for the rest of the flight. Okay, so we're up at our super efficient cruising altitude. Fantastic. But now we have a new problem. The air outside is completely unbreathable. The pressure is so low, our bodies just can't function. So to solve that, we basically have to create our own little bubble of atmosphere inside the plane. Now, we pressurize the cabin to what it would feel like at about 8,000 feet. And you've seen this happen with a bag of chips, right? On the ground, it's flat, but once you get up in the air, it puffs up like a balloon. That's because the air inside the bag is now at a higher pressure than the cabin air. Well, the exact same thing is happening to the gases inside your body. They expand, which, is why you might feel a little bloated. And that begs the question, right? If we're already pressurizing the cabin, why not just make it feel like you're sitting at the beach? Why the 8,000-foot compromise? Well, the answer to that question was learned the hard way from a truly terrifying incident in aviation history. You have to understand that every single time a plane takes off, the fuselage, the body of the aircraft, puffs out just a little bit from the pressure, and when it lands, it relaxes. Now imagine doing that over and over and over. It's like bending a paper clip back and forth. Eventually, the metal gets tired. It's called metal fatigue. For Aloha Airlines Flight 243, that cycle had happened almost 90,000 times, way beyond its design life. The result was a catastrophic failure. A huge section of the roof just peeled away from the aircraft mid-flight. It was an absolute miracle the pilots were able to land that plane. And the lesson the entire industry learned that day was vital. The greater the pressure difference, the more stress on the plane. So we keep it at that 8,000-foot level to dramatically reduce that stress and keep the aircraft safer for longer. So let's move from the structure of the plane to what's going on inside that pressurized cabin. Let's talk about some of the rules and, the refreshments. Starting with a rule that everybody asks about. Ah, yes, airplane mode. We hear it before every single flight. But let's be honest, is your little phone really a threat to this massive, complex aircraft? Well, the reason behind this rule isn't what most people think, and it's actually changed a lot over the years. See, the original fear wasn't about your text message taking down the navigation systems. Back in the 90s, the worry was actually about the network on the ground. The theory was that hundreds of phones traveling at 800 kilometers an hour could ping dozens of cell towers at once and just overwhelm the system. But the funny part is, this was never even really proven to be a problem. So here's the real reason the rule sticks around today. A single phone that's on and searching for a signal can sometimes cause a little interference in our headsets. It's kind of an annoying dit-dit-dit sound. Now, one phone is no big deal, but imagine 200 of them doing it at once. So, out of an abundance of caution, and frankly, to avoid the annoyance, it's just simpler to ask everyone to put their phones on airplane mode. Okay, moving on to the drink cart. Have you ever noticed that airline food just tastes different? A little bland? Well, you are not imagining it. The air that's being circulated through the cabin is incredibly dry. We're talking humidity levels as low as 5%, which is way drier than the Sahara Desert. So this super dry air, combined with a lower cabin pressure, actually numbs your taste buds. It makes it harder to perceive sweet and salty flavors. But here's the really weird part. Some studies suggest that the loud, constant drone of the engines might actually boost our ability to taste savory flavors, what's known as umami. And that might be the secret reason why about a quarter of all German passengers order tomato juice when they fly. It's a drink that many of them would never order on the ground. But up in the air, its strong, savory umami flavor punches right through that dulling effect of the cabin environment. And all of this brings me to my final, and I think my most important point. Now, it might seem a little strange to talk about accidents when we're trying to make you feel comfortable about flying, but the truth is, they are the absolute foundation of modern aviation safety. Every single incident, no matter how minor, is investigated with incredible precision. And the goal is never to just place blame. The goal is to dig deep, to find the root cause, and to engineer a fix so that that exact same thing can never, ever happen again. This relentless commitment to learning from mistakes is what makes flying one of the safest ways to travel in the world. Every checklist we use, every procedure we follow, every piece of engineering on the plane, it's all written with the lessons learned from the past. So the next time you're settling into your seat, I hope you'll see things a little differently. Not with any kind of anxiety, but with a real appreciation for all the incredible systems, both human and mechanical, that are working to get you to your destination. Now that you know the why behind it all, what are you going to notice? From the flight deck, safe travels.